Okay, let's get started. Hi, everyone. I hope you're all here and settled. Greetings to everyone joining us from different places, and welcome to the Revit edition of our Design with Qbiss One webinar series. My name is Urshka. I'll be your moderator today. With me is Aleš.
Hello.
He is the developer behind our Revit library, and both Aleš and myself work in Trimo's technical department, where we create different tools and documents to help you in your design process. In the first webinar of this series, Jure and Andraž focused on 2D design using AutoCAD dynamic blocks. In the first part of that webinar, they also made a Qbiss One product presentation. That webinar is available on Trimo Design YouTube channel, and you're welcome to check it out. Today, we'll skip the Qbiss introduction and go straight into the 3D environment and show you how to work with Trimo Qbiss Revit library. You should have received the download link for the start file via email if you want to maybe follow along. And it's also available on the Trimo website, where you can also find Revit Trimo term start files. We'll keep today's webinar concise, about 4 to 5 minutes. The plan is to make a quick introduction to the Qbiss One start file, followed by a practical demonstration of designing with Qbiss Revit library, and finally a short Q&A. So feel free to write comments, post questions at any time. We'll try to address them during the session or in the Q&A. Anything we can't cover, we'll follow up on afterwards. Aleš, what will be the final output of today's webinar?
Our final output will be the complete BIM model, including floor plans, facade views, and list of all facade elements. This list can be used to create a cutting list for material ordering. We will also go through the warning list, which highlights elements with dimensions that fall outside the production limitation.
Okay, let's move to Revit then.
Okay.
Aleš, please start with a quick introduction of the start file.
So when we open the start file, the first thing we see is the intro page with the basic information. Then when we switch to the 3D view, we can see two samples of the Qbiss facade. One is horizontal installation and the second one is vertical installation. We can see basic walls and ceiling with basic Qbiss panel, transversal corner element, longitudinal corner element, and 3D corner. We also added opening details such as window and door, and also linear finishing detail at the bottom and on the top.
Can you show us how these families work?
Sure. Let's zoom on the basic flat Qbiss panel. In 3D view, we can see that the geometry of the panel is simplified. That is intentional. We want to keep these families light, so they perform well, especially when we are working on large model. But once we switch to the layout, we can see more detailed geometry of the Qbiss panel. And we can also see that the length of the panel is controlled by the curtain wall grids, and the grid itself represents the center of the Qbiss joint. When we switch to the section view, we can also see the more detailed geometry of the Qbiss panel, and we can see that the horizontal grids control the modular dimension of the Qbiss panel, and the horizontal grid itself represents the border between the insulation layer of the Qbiss panel, not the center of the joint.
This longitudinal joint is the basic type. How do we now switch to the basic fusion or fusion joint?
We can do this by switching the panel type in the curtain wall settings, or we can individually change type of the panel by unpinning it and changing the panel type from Qbiss Basic to the Basic Fusion type or the Fusion Basic type.
And what about these different number types?
We actually have 12 types of the panel, but the first 4 are the most commonly used. These are the one that defines overlapping geometry of the transversal Qbiss joint. We will dive deeper in those a bit later in the webinar.
Okay, Alex, can you now show us how to start?
First, we will create a curtain wall. We can do this in our start file, or we can copy one part of the facade and paste it directly to our project file. We recommend keeping the start file opened in the background. This way we can easily copy any missing family settings or schedules whenever we need them.
So not all families get copied automatically.
No, only the currently used families and the types used in these families are copied for now. This keeps our list of families shorter and easier to manage. Later in this session, we will show you how to add any missing families or settings. Okay, in our project file, we already have architectural layout. We will use that to place our wall. We will create similar wall and we will pick geometry from right to left. We can see that the outer surface of the panel is also outer surface of our building. One important note here: do not use the wall flip command, because you would get the mirrored image of our Qbiss panel, and the type 1 panel will look like type 2, but in the schedule it will still be listed as type 1.
How can we check if panels are mirrored?
We are working on easier solution, but for now only method is a visual check.
Can we now set the wall height?
As usual, we can do this by setting the base and top constraint. We select newly created walls, and let me set the base constraint to level 2 and top constraint to level 3.
How do we control horizontal grids?
We can add them manually, or we can set distance to the fixed distance in our wall settings. Let me change this to 1200 millimeters, and we can see the change.
How do we now add vertical joints?
Typically, we follow architectural grids, and we can do this in a 3D view, or we can switch to the layout, where we can do the grids more precisely and faster. If we miss one, we can always select grid and align it to the architectural grid. Let us switch back to the 3D view.
Can we change the panel thickness at this point?
Absolutely. Panel thickness can be changed at any time. The fastest way is to select everything and filter out curtain wall panels. We can set different thickness of the panel without unpinning it panel, because the thickness is instance parameter.
So now we have a curtain wall facade with basic flat panels. How do we now add transversal prefabricated corner elements?
Okay, a corner element is also curtain wall panel family, very similar to the flat panel. Let's look closer to our sample wall. One side of the corner element is a part of the curtain wall and it is controlled with grids. The other side is a part of neighboring facade and it is controlled manually. In general, we mark sides of the corner element with A and B clockwise and also at the other side with side A and B. If side A is part of the curtain wall, we have side A variant. If the side B is part of the curtain wall, we have B variant.
So how do we choose the correct variant?
In our case, both variants would do the work. But let me choose the side B variant as an example. First, we need to replace these panels with empty panels. To do that, we must select panels along vertical grids, unpin them, and replace them with empty type panel. This prevents counting the panels twice in the schedule. Then, on the left column, we select panels along vertical grid and replace them with corner element. But we only have side A variant available. This is because side A variant was the only one included in copied section. If we want variant B, we must go back to the start file and under the project browser, we select curtain panels and variant B of the corner transversal family. And here we copy the first 4 types most commonly used and paste them directly to our file.
Why don't we just copy the entire family at once?
Revit doesn't allow copying a whole family this way. We could load family, but for this workflow is actually faster to copy just the types we need. Now let's select this column of the panels and replace them with side B variant. If we choose this grid, we can see that the length of the side A should be 1000 millimeters. Let's choose corner elements and set the length to 1000. Okay, let's check in the layout and we can see that the joint fits perfectly.
And on the left side of the building, we will have side A to be part of the facade.
Yes, exactly. We will replace the entire left facade column with corner elements. So let me just delete this left facade and select this column of the panels, unpin them and replace them with side A variant. Now we must set the length of the side B here and we need here 3000. Let's check the layout and we can see that it fits.
What about the longitudinal and 3D corners? Do we insert them the same way?
Yes, the principle is the same. One side of the corner always follows the facade you are working on, and the other side are driven by numeric parameters.
Onto the opening details. How do we place windows in the facade?
In Qbiss facades, openings usually fit modular dimension. It's like removing panel and inserting window instead. We insert window simply by unpinning the panel and replacing it with curtain window detail. In layout, we can see that the alu frame of the window fits the Qbiss joint. Same we can see if we switch to the section view.
We see the door opening fits 3 panels instead only 1. How do we fit the door here?
First, we need to remove the grid segment. Then we unpin the panel and we replace it like we did with window. Or we can do it with match type command.
What if our window doesn't fit modular dimension?
Then we can use our typical detail with overlapping alu frame. We can simply copy this detail from our start file and paste it directly to our facade. Then we should do the cuts. First, we select the panel and then window detail. Then second panel and window detail. Sometimes we need to use tab on the keyboard. We can see that the cut didn't go through the panels, so we need to increase our thickness parameter. Now we can see that the cut did go through the panel.
Okay, we've now defined the bounds of the building. Can we now, for example, change the module back to 1000 millimeter, but keep the window row at 1200, and then maybe set the top level to 5200?
Yes, changes can happen at any stage of the design. Let's edit this curtain wall type and set the fixed distance back to 1000. We will see that the modular dimensions of the panels and the openings will adapt to new value. In case we want only this row with window 1200, we can do this by selecting all grids above the window, filter out the grids, unpin them, and now we can move them up for 200 millimeters. We will see that the opening has become larger. We have set the top constraint of this wall to the level 3, so we can try to change this level, let's say to 5200, and we will see that the height of the wall have changed.
We talked a bit about inserting doors and windows. What about the finishing details at the top and bottom?
Our main focus were panels and corner elements, but of course we need to define fixing, flashings and ceiling material in order to build facade properly. All these materials are defined in Trimo typical details which are available on our website. For now we do the calculation of this material separately from Revit model but we prepared Revit families for visual representation and detail length calculation. Families are mullions, structural framing, and structural columns, depending on which kind is most effective to be used.
We already use mullions as fixing details on vertical grids. Can you show us how to insert the base detail?
Okay, we will use this structural framing family for base detail, and we will create similar. Make sure that 3D snapping is on, and we will use these pick line tools to pick edges where this detail comes. We pick this one, this one here, and also this one. With grips, we will set the length of the detail properly. We must do this one by one. Okay, this is the last one. The base detail is set.
Can we do the same for top parapet?
Of course, only we must copy one instance from start file. And we will create similar with picking edges. We will pick this one, and this one. Sometimes we need to disallow joint in order to make these edges properly.
If the elements overlap, can we join them at 45 degrees?
Yes, we can. We will switch to layout, and we will first draw the reference plane here, and we will make it 45 degrees. Then we will choose one, and we will cut this edge at this one and this on this one. We can do this for all edges. If we use mullions, all these adjustments are done automatically.
Okay, now we need to finish defining the Qbiss elements, and we need to look at the transverse joint endings, the Qbiss types. We have 12 different types, and each one is a combination of 3 possible endings. The first option is an ending with insulation, the second is an overlapping ending without insulation, and the third is so-called cut ending. In practice, the first 4 types are the most used. So type 3 is typically the starting panel. Then we use type 1 when installing toward the right. Type 2 is used when installing toward the left. And type 4 is usually the terminal panel, and it's sometimes produced only after the site measurements are complete. Ales, show us how we do all of this in Revit.
In curtain wall definition, we have chosen type 1 to be default. If we want other types, we have to individually unpin the panel and choose other types. To do it easier, we added ending presentation to all Qbiss families. We must switch to fine detail level to see those marks. We also made color presentation. Under graphic filters, we will switch them on to see this presentation. green panels are type 3. Here we usually start installation. Also, they often come between openings. Type 3 has ending with insulation on both sides. Then we have white type 1, which overlaps this ending with insulation, and installation goes to the right direction. Similar to type 1 is type 2, only assembly goes to the left. Those panels are in blue. To complete installation, we have red type 4, which overlaps both of the panels, and we usually end installation here.
So you need to know the installation direction to complete this task.
Yes. Let's assume that we will start installation on the left and we will continue it to the right. First, let's switch detail level to fine to see marks, and we will select these corners and we will make them initial type 3. All other panels are type 1 and they overlap each other to the right. Except panels right from the openings, where we need ending with insulation on both sides. We will select them and pin them, and we will make them initial type 3. And installation here goes from initial type 3 to type 1 and all around the building. Okay, we are done.
We have one last definition left. How do we determine how many fixings are required to hold each panel in place?
First, we need static calculation where we can find how many screws per panel are required. Minimum is 2 and maximum is limited by panel modular dimension, because we have C washers pre-installed on overlapping endings. Through these washers, panel is fixed to the substructure. Maximum number is calculated automatically. We put required number from the static calculation to user fit, but not higher than the calculated maximum.
What else do we get from static calculation?
Static calculation checks if panel with chosen thickness, steel sheet thickness, profilation, and mineral wool core will carry load on required span. Panel thickness, steel sheet thickness, and profilation is usually same for all panels. Only mineral wool data sometimes varies. For bigger spans and corner area, sometimes wool with higher strength is required. Usually we have power T. For higher strength, we have power S.
Can we make only one row of panels a different color?
Sure, let's just pick them and select different color material. Let's choose 9002, the white color. The same is for all facade elements with external color property.
What if we need a color that isn't on the list?
We can create new Revit material, but we should check the color chat in Qbiss book for available colors.
Okay, so we're done with modeling and panel definitions. Now we would like to order all materials for our facade.
Let's do that. We will do the schedules for all Qbiss elements in model. Let me just delete this copied part, which we don't need anymore. Now, let's check if all Qbiss elements are within limitation for production. Qbiss families have series of if sentences which check if all parameters are within its limitation. If not, warning appears. Not all potential imperfections can be spotted for this procedure, so for more complex situations, please check our technical documents or contact our technical support. We have prepared warning list schedules, so let's copy all schedules from the start file and paste them to our file. Now let's open our Qbiss panel limitation warnings. We can see that some corner elements have R value which is length too large to be produced. Let's highlight them in the model.
Can we split this corner to be shorter?
Not directly. We will shorten B side to 1000. And now we should create new wall in here. We could use the create similar command and place wall here, but there is a faster way. Let me copy this part of the wall here and let me delete this grid. We will rotate this wall to this position. I will do this in the top view. This grid I will drag here, and this grid will go here. Let's check in 3D view. The wall fits and the panels have the same properties as the right one. Now we need to adjust the installation direction. This corner is initial, and here we have installation to the left, so these panels should be changed from type 1 to type 2. I will select all panels on the host and pin them and change the type 1 to type 2. We can see now that everything is okay.
Okay, let's check the warnings again.
Okay, no warnings now.
Can we generate a panel list for the cutting list?
Yes. Let's open Qbiss panel schedule. We can see all Qbiss elements from the model and their properties like thickness, model length, and the quantities. If everything is okay, we can proceed further.
Can we generate a panel list for the cutting list? We should group panels that share the same properties under the same mark number.
Yes, we can do this in Revit. Let's do this for the panels first. If we open the Qbiss cut list, panels are already joined under the default conditions.
I see a varies value under external color. What does that mean?
It means that the multiple color is joined under the one mark number. This is not okay. Let's check sorting and grouping. We can see that we can group panels under 4 conditions. In our case, our panels are horizontal and they have thickness 200. But we have two colors, so I will set this first condition to the external color. Next, we will set the module and we will set this descending order. Fourth will be the length of the panel, also descending, and the last one will be the type of the panel. Now let's try again.
What if more than 4 properties vary?
Then we should use the filters and do this in more steps. Let's see at the list now. We have panels arranged from white to gray, from larger model to smaller model, and from larger length to the shorter length. If this is okay, we could fill in the mark numbers from the one to the last one. Same we do for the corner elements, but on the other list.
Can we add a prefix to the tag number so that we can see which facade each element belongs to? That would help us organize the construction site better.
I would leave the mark numbers as they are, so we can see which elements are truly the same. To add facade prefix, we should go back to the model and select all panels from one wall and set the facade prefix, let's say, to A, and for this facade to B, and for the last one, let's set this prefix to C. If we go back to the cut list, we can see the facade prefixes, and we can see that some panels with same mark numbers are on different facade. Let's change the sorting first to the facade and then to mark number and ascending. Others will be set to none. And now the list is facades from A to C and mark numbers. Everything looks okay now.
Now that we've completed the cut list schedules, can we transfer them to the Excel cutting list?
Yes, first we need to export the schedule to the text file. Then we transform this data to Excel spreadsheet, and from them we can copy to the cutting list and make an order.
So the model is complete with all data, and we've created the schedules with position marks. Can we add some text to the Qbiss elements in elevation drawings?
We do elevations like any others in Revit. Let's open the south elevation. We can see facade already with all Qbiss elements. To add tags, we should copy the Qbiss tag first. We can find it in a start file under annotation symbols, and we simply copy it to our file. We add all tags by tag all command. We can see that the Qbiss tag is already selected for curtain panel tags. We click OK, and the tags appear on the drawing.
What if we only want to display the mark number and prefix?
We can reduce additional data by editing tag. We simply click on and edit family for the tag. We can edit label and reduce some data from the tag. When we are done, we should load back this tag family. and now we can increase scales.
Thank you, Aleš, for this great demonstration. Now let's move to the Q&A. Since we are running short on time, we'll answer just one question, and all remaining questions will be answered afterward in a compiled document, which we'll send to you together with the recording. Okay, a question about sharing IFC model with others. Which information can we share?
IFC is commonly used format to share model geometry and some additional information. Let me share my screen. In Revit, we can see our model and we can export this model to the IFC format. Under the Modify setup, we can choose which properties we will share along with model geometry, and to share panel properties, we should check on the Export Revit property sets. Other settings we can leave as they are. Okay, and then we export. The exported IFC file we will open in the Autodesk viewer, where we can choose individual panel, and we can see the panel properties such as thickness, model, length, external and internal color, and also the mark number and the facade prefix. If you can't choose individual panel, you should, under the settings, select the last object. Okay, this is it from exporting IFC.
Okay, and with that, we're at the end of today's webinar. We hope you learned something new and gained a clearer understanding of how to use Qbiss Revit start file. In the next few days, we'll send you the recording and the Q&A summary. Before we conclude, we would like to invite you to visit our YouTube channel, Trimo Design. We've prepared playlists on using our BIM libraries, and there you'll also find videos covering design principles, installation guides, and more. We'd love to hear what you think, any comments or ideas that can help us make our content even better. Thank you again for taking the time to join us today, and we hope to see you again. Next webinar in the Design with Qbiss 1 series will be the ArchiCAD edition. On behalf of Aleš, myself, and the entire Trimo team, wish you a pleasant day and look forward to seeing you next time.
Bye.
Bye-bye.